Isabella. I'm one of the co-founders of Tangram. This is David.
Hi, everyone.
We make a CLI and web app that makes it really easy to train, deploy, and monitor ML models so you can make predictions directly in your existing applications, Ruby, Node.js, Elixir, Rust.
And more. You can go to our website, tangram.dev, check it out, and we're sponsoring a challenge. So we're encouraging all of you to incorporate Tangram into your hacks, make something cool with machine learning.
And if you like our project, give us a star on GitHub.
Very much appreciated. Okay, so in this workshop, what we're going to do is we're going to show you how to use Tangram to replicate a feature kind of like in VS Code. So recent versions of VS Code allow you to do something like this, where you create an untitled
Can you guys hear it?
should I remove my mask?
Can everyone hear what he's saying?
Yeah.
Okay.
Yeah, I think you're good.
I'll try to scream. This did not work with this code. Hold on one second. So I'm just going to grab some sample code and paste it into a new document in VS Code. And if VS Code is behaving correctly, which it isn't, just a moment, I'm going to grab a different one. It should.
Live demo.
Yeah, live demo. It should automatically highlight it, which it's not.
So VS Code sucks and it's not automatically highlighting this code, but it does, and it's a new feature of VS Code.
Right. So what it does is, as when you open a new document, as you're typing, it automatically detects what the programming language is. What we're going to do is we're going to try to make an app that has similar functionality. So I'm going to close this out. And we're going to try the impossible, which is to live code. So over here, I have I created a new project with NPM. I set it up with Webpack. How many of you guys have used Webpack before? Maybe this person.
We can post this to GitHub too.
We'll post the code to GitHub. But basically, you created a new Node and NPM project. You add Webpack. We add the Tangram library, which we'll show you in a sec. And then we add some stuff to automatically transform your code so you can use React. How many of you guys have used React before? A few. Okay. So right now, all the code does is it just displays hello world. So I will jump over to our app over here, and you can see it says hello world. So what Isabella did before this is she prepared a data set. Here it's just done in Airtable. You can see how there's two columns. The first column is the programming language that that the code is written in. And then over here, there's some example code snippets. So you can see over here, this looks like some Python code. This looks like some Go code, package main, etc. Down here, there's some Python code, import RE, etc. And we can download it as a CSV file. So right here in this folder, I have this PLD programming language detection.csv file. And we can train a machine learning model to predict the language based on the code using the Tangram command line tool. So I'll say Tangram train. I'll pass in the path to that file, pld.csv, and then I'll specify the target column, which is the name of the column we want to predict. In this case, it is lang. And when I hit return, what the command line tool will do is it will automatically figure out what's going on in the CSV file, train a bunch of machine learning models, now it's trained 2 out of 8, across a range of hyperparameter settings. It will pick the best one, and it will write it to a file in this directory called pld.tangram. And that .tangram file contains everything you need to make predictions. You can make predictions from just about any programming language. In this case, we'll do it for JavaScript. So let me jump back to the code. And to get started, what I will do is I will delete this, and I'll just get started with like a really simple React app. So I'll import React. What else I need? React DOM. I can create a new component called app, and I'll say React DOM.render app. I can grab the elements that I need. And let's make sure that this component actually returns something. So let's just make this hello world, make sure that React is working. Is everyone slightly familiar with what's written so far? Creating a React component and then rendering it. Let's jump in here, and you can see it still says hello world. Okay, next. What we want to do is we want to add a code editor that looks something like VS Code. So we can download this package, I've already added it here, called React Ace. And then we can start to use it. I can import it like this, and then I can render one over here. I'll say Ace Editor. And then I probably need to specify parameters for it. Nope, I think just like that, it should already start working. So let's jump back to our app and see what we get. Webpack takes forever to build, but it ends up working. So hello world. Now I've got something that looks like a code editor. Next, let's add a theme to it and prepare our syntax highlighting. So I'm just going to copy this code that I have left over there. Here I'm just importing the GitHub style theme and then adding this editor calls modes, which is like the syntax highlighting capability for JavaScript, Python, Golang, and Ruby. Those are the 4 languages that we're going to be detecting. And what I can do is I can specify one of the modes, like I'll say like right now I want it to be JavaScript. And if I jump over here, now I should see JavaScript syntax highlighting after this rebuilds. So just a sec while it loads. And I can type in function hello, and you see how it highlighted the word function, because function is a keyword in JavaScript. Next, what we can do is we need to use React State to keep track of the current value. So I'm going to say let code, set code, equal to use state from React. And by default, it will be the empty string. And then what I can do is I can create an onChange function. This would be code. We can set code with that new code whenever this Ace editor changes. So I can say onChange equals onChange. And then I have to set the current value equals code. So now this is what's called a controls component, where I have a variable code that will always refer to the current text in the editor. I'll double check that, make sure it still works. Yep, still working. All right, next we're ready to load in our machine learning model. So I can do that by loading the Tangram library. So I'll say import star as Tangram from tangram.dev Tangram. I had to add that to my package JSON as well over here, and then run npm install. If there are any questions, by the way, feel free to interrupt, no problem. So now that I have the Tangram library loaded, now I need to grab my model. So I'm going to copy this code over here that I've saved and bring that in. What this code does is it grabs that pld.tangram file from the training on the command line that we just did. And what I do is I download the model and then load it. I say new tangram.model to load it. So now I have my model and now I can make a prediction. So why don't I just add a console.log for now. I'll say console.log model.predict. Given the new code, I'll make a prediction, and I can print out the class name to see which class was predicted. So I'll jump back here, grab on my pasteboard some example code, like here's some Python. And when I paste that in, what do we get on the not seeing it. Change. Let's see what Webpack is doing. It says it's compiling.
So slow.
I know, it's so slow. Why is there so much output here? Okay, so the console.log is not showing what I expect, but I will keep trudging through. So what we also need to do is we need to print out the language. So I'm also going to add some state for the language, which will be null by default, but we'll set it to the language that we predict as we go. Then what I can do is I will add a little bit of additional info over here to show the detected language. So it'll be null initially, and then it'll be the language that we expect it to as soon as we enter in some code. And then we need to set the language. So whenever we set the current code, whenever the text editor changes, we also want to set the language.
Here's the return.
Where?
Oh, for the code.
Oh yeah, thanks. All right, so now what we're doing is we're setting the language with the result of predicting with the model and updating the code in the text editor. So let's reload, grab some example code. I'll grab some Python over here. Yeah, I know, moment of truth. There you go. And you can see how it detects that the language is Golang, and you can see how it correctly highlighted. Like func is a keyword in Go, and so it highlighted that. Let's try another example.
So this data set has like what, 135 records. The actual model trained for VS Code is millions of records.
So I just grabbed some JavaScript, and you can see it's detected as JavaScript, and it's highlighted correctly, like the import keyword, function, new, etc. Cool. So that's the whole thing. Any questions? Yeah, what's
So
up?
like, this is all text-based, could it do it with like images or something?
So Tangram doesn't work with images right now. It works just with numbers, categories, and text.
Coming soon.
Coming soon, images, definitely, yeah.
We have one question from Anonymous. They're asking, what is Tangram?
All right, yeah. So Tangram is a CLI and web app that makes it really easy to train machine learning models on the command line and then learn about them in your browser. Do you want to?
Yeah, sure, let's pull it up.
We can show how to use.
Yep.
So anyone who's used to training machine learning models knows that usually you do it in Python, you have a Jupyter notebook. Getting that model deployed into production at companies is really hard. So there's a lot of companies that are startups now that are trying to get Jupyter notebooks into production. That's not such a great solution because the Jupyter notebook is not so stable. You know that if you run the cells out of order, like it's Tizen. So you want something that's a little bit more deterministic. And you also want it to be easier to get machine learning models into production because a lot of machine learning models just go to waste because data science teams start tweaking parameters and they never see the light of day. And so we built Tangram to empower regular software developers to be able to train machine learning models on their own and deploy them into their existing applications without coordinating with ops teams, back-end teams, if they're a front-end team, etc.
So after training that model on the command line, what you can do, so we have this cool app where you can upload the model. So let me just grab it under downloads, sorry, just under programming language detection, tld.tangram. And there's this cool app that shows you all about your model. It shows you a training loss curve, accuracy. You can see the model was 85% accurate, predicting the programming language. You can see which features were more important. You can check out the hyperparameter grid, so you can see all the models that were trained until the best one was chosen. You can see how the model performed on the test set. So the most obvious thing is accuracy, but there's also precision, recall on a per class basis. You can look at metrics for each class. So if I pick one of the languages, like Ruby, I can see the confusion matrix for it. So you get like a lot of explainability into your model so you can understand how it works. And this kind of matches what a data scientist would do in a Jupyter notebook to explain to people around the company how a machine learning model works.
Except for Tangram, it just does everything automatically and then shows you this consistent user interface information about your model. We didn't give our intros.
Oh yeah, so
We can give our intros. So I'm a 2014. David's also a 2014. I ended up as an ML engineer at Slack, one of the first on the ML platform team there, and saw a lot of problems getting ML models into production, and that kind of motivated David and I to work on this. David was at Facebook at the time.
So at Facebook, the way the machine learning worked is for across all the teams, for every 5 or 6 front-end and back-end developers, there was at least one machine learning engineer and one data scientist. And they were supported by a huge central org that made all sorts of internal tools. Our goal at Tangram is to give similar tools like that and similar capabilities to companies to have their front-end and back-end programmers train machine learning models and get best-in-class reporting, explainability, monitoring, etc.
Yep. And we built everything in Rust. I know some people are excited about Rust.
Yeah.
Our front end here is Rust too.
we'll be giving a talk later, like a good intro to Rust for people who are interested in it.
Our second question from Anonymous is, can I use this package for free in any of my projects?
Yep, so everything that we showed you on the training on the command line and making predictions in any language is totally free and open source. And then the application, the web application is free to use for personal use, but we charge companies to use it in the real world.
So for any hacks.
Yeah, and it's definitely free for all hacks.
Okay, we have one more from Anonymous.
Same Anonymous?
Same Anonymous, awesome, who knows? What kind of machine learning models does Tangram use?
Yep, so there's two model types, linear models and gradient boosted decision trees. And then there's three tasks, regression, binary classification, and multi-class classification. The gradient boosted decision tree algorithm is one of the best performing for tabular data sets. Most companies who are doing like fraud detection, lead scoring, are either using linear models or gradient boosted decision trees. Neural networks are super exciting, but they don't perform very well on tabular data sets. I think that will come in some years, but right now it's still a research paper when a neural network works well on tabular data.
And a lot of companies that like the speed and simplicity of the simpler model types.
Yeah, we have some hacky stories.
Yeah.
Simple models win.
Yeah.
And we actually wrote our own gradient boosted decision tree library in Rust. So if you're interested in learning about Rust, I gave a talk at RustConf this last week, although I recorded it like a month ago. So it's on YouTube. You can learn about how we optimize our GDP implementation. We had to beat Microsoft, so we worked really hard.
Okay, we have a question from Kosi this time. How did you build your front end in Rust? Did you use web workers? Or did you build your front end in Rust, I guess?
Yeah. So everything you see here, like most of it's server rendered, so it's kind of like writing Ruby on Rails. We just generate some HTML on the server and deliver it down, but some of the stuff is interactive. So if I go back to the home page, you can see there's a chart. Charts are interactive. There's a few other widgets that are interactive, and all of those front end things we chose to write in Rust for simplicity, so that we have a single language across the entire code base. It allows us to reuse code really easily and avoid having to manage multiple tool chains. JavaScript in particular is notorious for being difficult to manage. Sorry, what was that? What was it?
Was
ask the
it
question?
written in Rust? Oh,
Yes.
so you can talk about WebAssembly.
Yeah, so what you do is you write your code in Rust. And Rust is a compiled language. It's not interpreted natively by the browser, so you have to compile it to what's called WebAssembly, which is a binary low-level format that modern browsers now support.
And this was kind of like a big technical decision for us, maybe interesting for some people. We wanted a server rendered application, so when you make a request, you actually get the HTML and it renders immediately. Some single page apps, you make a network request, you don't get a full set, like, what is it?
HTML.
Yeah, you don't get HTML, what is it called, hydrated.
Yeah.
You don't get like a fully functional HTML document. It starts, the JavaScript starts up and then it builds up the HTML document after.
You've probably seen a lot of like modern web apps where you go to the page and there's a little spinner and you wait, and then finally you
Yeah.
see something. That's
So
a
we
clear
didn't want
sign of a
that.
single page app.
And if we didn't want that, then we had to render the web application in our backend, and our backend was written in Rust. So we had two options. Write our front end to be compatible with Rust, or make a JavaScript interpreter available to our backend. And we decided not to do that.
Yeah, it's also, server rendered apps, while they're kind of not in fashion these days, they're a lot easier to manage. They're a lot easier to think about because, a user makes a request to the backend and then receives HTML, and that's it. Whereas with single page apps, what you have to do is you have to manage two separate processes. One is in the server, one's on the client. And you have to download, usually the client has to make network requests back to the server, collect the data and present it, and deal with all sorts of caching problems. So, like, I use the Gmail web app, and like so often, I see drafts that I just deleted, send to mail, it shows up in my inbox, etc. Maybe you've experienced something similar. Caching issues are very difficult with single page apps, and we were trying to avoid that.
So it's Rust all the way down.
Okay, another question from Anonymous is, did you learn about machine learning at MIT, and if so, which classes do you think were the most helpful?
I would say that everything has changed since we were undergrads, just like 7 years ago.
Yeah.
There was one class, 6034, with Patrick Winston, which we both took. But other than that, it wasn't really discussed much.
Yeah,
Now- nowadays
I
I've heard
think
there's a lot.
6036 is just like a brand new baby class, and
Yeah,
now it's
yeah.
like, and now I feel like you guys have like several classes that are ML oriented.
Yeah,
Yeah,
but
take
so
that.
we can't recommend anything because they're all new.
Yeah, we were self-taught mostly.
Okay, now we have a question from me.
Great.
Alright, so like, what do you think about the Rust package ecosystem compared to like the JavaScript package ecosystem?
It's a really great question, actually. I would say that the Rust package ecosystem has some things missing, but on average is really, really great because the Rust language has attracted some really, really great developers, and it's a very strongly typed language, and so the result is the software is very reliable and well designed. Actually, it's a big attraction to using Rust is getting access to the package ecosystem. Even though it is today not as mature. But for things that you do every day, the Rust alternatives are much stronger than the JavaScript alternatives, in my opinion.
Safer too.
Yeah, and much safer, exactly.
Okay, I guess we have time for one more question from Anonymous, which was, how were you self-taught? What do you suggest to learn more about ML?
Oh, okay. So I'd say like the canonical course is Andrew Ng's Coursera course. I think everyone that I worked with in industry has at least audited that course. You can read a bunch of papers too. There's a lot of like really good ML papers in order to implement gradient boosted decision trees. I read all of the GBDT implementation papers like XGBoost, LightGBMs, CapBoost, and you can read a lot of source code. Do you have any more suggestions?
Yeah, my suggestion is just to start playing around. Open a Jupyter notebook, download some Python packages, and poke around a little bit. You definitely get a feel for it through experience. But if you want the highest level interface, try Tangram.
That's it for questions from Slido. Does anyone in person have questions?
How do you manage kind of like being self-taught and like exploring your passion while also managing classes here
I would say I was self-taught after
after?
school.
Yeah, while you're at MIT, there's nothing.
Yeah.
There's no free time.
And you learn on the job too.
Yeah.
You do a lot of learning in your work. I would say like actually learning how to program doesn't really happen in class. It happens in your work, in your internships.
Yeah, so certainly I would say, based on my experience at MIT, is if you have the opportunity before you go and get your first job, try to spend more time doing practical things. I mean, this is kind of like, doesn't even make sense to give this advice at Hack MIT because clearly you are all trying to do very practical things, but it's possible to get through course 6 at MIT without spending that much time with a computer actually trying to implement things. And so I definitely felt a little unprepared going into real world jobs, just like missing what many people considered basic knowledge. And so
We know about Bellman Ford, but we never had to use it.
yeah,
I
that's
love
definitely true.
646, one of my favorite classes, but never had to use that.
Yeah.
Maybe you have to for your like quant interviews.
Yeah, and certainly the interviews are far more theoretical than your actual work. All of the memes that you see online, like the whiteboard interview versus what you actually do, yeah, it's all true.
Did you use a WebAssembly framework to make that site, or did you somehow like write it from scratch?
So the first thing you have to do is you have to use this project called Wasm Bindgen. You can just Google it, Wasm-Bindgen. What it does is it creates this bridge between WebAssembly and JavaScript so you can interact with the DOM APIs. That allows you to do things like the equivalent, just 1 second, of what we started out with here. Just undo all the way back to the beginning. document.create element. That's like, the most fundamental DOM operation. So you can have an equivalent of that in Rust. It will compile the WebAssembly and have a JavaScript bridge that allows you to talk to the browser. Everything on top of that is basically your responsibility. There are some higher level libraries. There are libraries for Rust that look like React and feel like React. We chose not to use them because for a number of reasons. One reason is that the JSX syntax doesn't play so nicely with the Rust language capabilities in VS Code, like go to definition, find references, refactoring, etc. It's really great in VS Code with TypeScript because TypeScript natively supports React's React syntax. This stuff down here, like if I grab this and I can jump to definition, I just hit a keystroke and I can immediately go to that particular class. So we wrote some small library that feels in some ways kind of like React, but is all in Rust.
It's all on GitHub.
Yeah, it's all on GitHub. You can check it out. Does that give you a good answer to your question?
Yeah.
Okay, I think that's it for the
Cool.
talk. Thank you guys for coming.
Well,
Thank you so much for sharing that.
if you guys have more questions, feel free to talk to us after this. We'll stick around.